one knows how far we'll get into this. There. A couple different definitions, and this is one of those things where I'm sure you'll leave slightly confused today, but the more you talk about it, the more you think about it, the more you'll see it, the more you deal with it, the more clear it becomes. First of all, if something varies directly, vary means changes. If something changes directly, okay, it simply means this. As one thing goes up, comma, so does the other. Which won't make any sense to you until we talk about this. For example, speed compared to distance is direct variation. Okay, let's say you're traveling in a car. Your car, you're going 30 miles per hour. Okay, 30 miles per hour. Here is my little table. I'll make a little table of speed. Well, we'll go time and distance. Okay, if you talk about speed, if you're going 30 miles an hour and you drive for 1 hour, how far have you gone? 30 miles. If you travel for 2 hours, how far have you gone? 60 miles. Notice as the time goes up, so does your distance. Okay, if you went for 6 hours, how far would you have gone? Wow, somebody out there. Okay, 180 miles. Now, most things we think about are directly related or there's direct variation, but there's some things that wouldn't. Okay, if there's direct variation, there's probably indirect or inverse variation, we call it. Things like this, what would be inverse variation? It would be something that as something goes up, something else goes down. Well, how about this? How far you travel and the amount of gas in your gas tank. The distance you travel goes up, while the amount of gas in your gas tank goes down. That would be inverse variation. But most things we think about, actually it's like this. You know, pay. If you make $40 an hour, the more hours you work, the more you get paid. If it was, fortunately for you, pay is not inverse variation because basically that would say the more you work, the less you get paid. So that's a little screwed up. Now, with that, here is what you have to understand. Here is the direct variation equation. Just like, remember we talked about linear equations that y equals mx plus b. When we talk direct variation, this is what they give you. Y equals k times x. I'm going to spend a little bit of time making it look nice just so you can see how important this is. This is the direct variation equation. Say that about direct variation equation. And in this equation, okay, the letter k is the important part of this equation because k is what we call the constant of variation. A lot of big words that mean absolutely nothing, actually. But we have to learn them just because. In layman's term, your constant of variation is what you are always multiplying by. I will show you. This will become crystal clear in 2 seconds. Going back to this whole thing, using this equation, what did I always multiply by to get the second number? 1 times what, 2 times what, 3, 6 times what? 30. My constant of variation was this. This was my letter k. And if I were writing the equation out, I would say y equals 30 times x. Well, not always do we use x's and y's. This time I use t and d just to help. But this, you would put this as x, and this would be y. Okay, or you could say d equal 30 times t. My constant of variation was 30. You will actually. And I'm glad you brought that up, Cameron, because that's the next thing to talk about. Direct variation is also the same thing as being called proportional. If something has direct variation, it is also proportional, which is what we talked about, the whole balloon thing. When you blow up a balloon, the more air you put in it, the bigger it gets. It'd be bizarre if you blew into a balloon, it actually became smaller than the more air you put in it. It just doesn't work. Okay? So in order for things to be direct variation, two things have to happen, just like with being proportional. Two things must be true. The first thing that must be true is if you graph it, it goes through the origin. Okay, it goes through the origin. And the second thing that has to be true, okay, is that as one goes up, comma, the other goes up with a constant of proportionality. I'll tell you what that means in a second. And this would actually mean it has to be a straight line. By the way. If you look at this handy dandy little table I have here, and you look at how the numbers are related, is it true that as one goes up, the other goes up? You know, this went from 5 to 7, and it went from 15 to whatever, 19. This one went from 8, went to 24. So, as one goes up, the other goes up, right? But before you check to see if it's actually direct variation, you have to think about what is its constant. So you ask yourself, to go from 5 to 15, what do I have to multiply by? 3. To go from 8 to 24, do you multiply by 3? To go from 7 to 19, do you multiply by 3? No. And if you can't, if that's not true, because it has to be the same for true, this is not direct variation. Okay, it is not. It has to be, every one of them would have to be times 3. This would have to be 21. And then if you did graph it, let's graph it since it is, let's make it directly proportional and change that to 21. 5, 15, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, let's just put it up there. Oh, I don't want to do, can I go less? Let's put 1, 3, 1, 1, 2, 3, 2, 6. 1, 2, 3, 4, 5, 6. And you can see that these will fall in a straight line, and they should, and they have to go through the origin. You have to come up with 0.00. If I put 0 in this, do I get 0 over there? Yes. Okay. Let's get here. And please also note this. If I gave you this graph that looked like this, and I gave you this line, and I asked you if that's direct variation, yes or no? It's a straight line, and it fits that one. But does it go through the origin? No, so this is not, it's not proportional, nor is it direct variation. It is not direct variation. It has to go through that point right there, otherwise it's a no-go. Let's see what they ask about this. Maybe it's not such a bad thing. No, we're gonna stop right there. Will you stop?